Hello class. If you missed class today because of the assembly, here is a video of the notes of what we did today, and then your homework is to finish the rest of the stuff that we did in class, which I told you about this morning. So for example 3, if you get out the notes packet on velocity from last class, we're going to do example 3 and 4. So the key thing with any of these graphs is to always read the instructions, because they tell you which graph you're given. So number 3 says the accompanying figure shows the velocity of v of t, which equals f of t, of a particle moving on a coordinate line. Okay, so this is key thing, that this function is the velocity function with respect to time. So the first question says, when does the particle move forward, move backward, speed up, and slow down? So the first thing we want to answer is move forward. Well, the particle moves forward whenever the velocity is positive. So if we look at our graph, that means the velocity has to be positive. The velocity is positive when it's above the x-axis. So if we look at our graph, it's positive starting here at 6 until we get to 10. And we always write our answers for these in interval notation, and you always use parentheses because the endpoints, the velocity is 0 and not positive. So then for backward, we're going to look at when the velocity is negative, then the particle is moving backwards. So if we look at this starting at time, we're looking at our t values, or technically x values. It would be starting at time 0 until we get to here at 5. And this is when v of t is less than 0. The next question says, when does the particle speed up and slow down? So if you remember from our notes last class, we talked about how a particle speeds up when both velocity and acceleration have the same sign. So the key thing is to find the sign of acceleration. Acceleration is the slope of velocity. So we have to figure out the sign of the slope in order to know the sign of the acceleration. So if we look at here, starting here, well, my slope is 0, so that means my acceleration is also 0 during this time. But then starting at time t equals 2, now my function is increasing. And anytime our function is increasing, we know that the slope is positive. So that means a of t is a positive from 2 until we get to 5. And then from 5 to 6, again, our acceleration is 0 since it's a constant slope. And then we start looking at 6. So if we look at our slope at 6, it is, again, increasing. And so since it's increasing, we know that the slope is positive. So that's from 5 to 6. And then starting again at 6 until we get to 8, our slope is 0. So a of t is equal to 0. And then from 8 until we get to 11, my function is decreasing, which makes my slope negative. So we found our slopes. Then we have to compare our slopes to our velocity. So our velocity, when we are at from 0 to 2, would be negative. So anytime my velocity is below the x-axis, it's negative. So actually from 0 to 5, my velocity is negative the whole time. And then we already said from 6 to 10, my velocity is positive. So we want when they have the same sign. So our particle is speeding up, okay, anytime they have the same sign. So if we look, acceleration 0, so it doesn't have a sign. Starting at 2, my acceleration is positive, but my velocity is negative. So it's not speeding up at that time. Starting at 6, my acceleration is positive and my velocity is positive, so it's speeding up from 6 until I get to 7. And then at 6 to 8, acceleration 0, so it's not speeding up or slowing down. From 8 to 9, my acceleration is negative, but my velocity is positive, so it's slowing down. And then from 10 to 11, my velocity and acceleration are both negative, so from 10 to 11, it's also speeding up. And then the last part of this problem is slowing down. So it's slowing down when velocity, acceleration have opposite signs, so that would be from 2 to 5, and from 9 to 10. Right here. It's when velocity is positive and acceleration is negative. Okay, part B says, when is the particle's acceleration positive? Well, we already kind of figured that out, so this should be easy to answer. So positive whenever the slope is positive, so that's from 2 to 5, and then from 6 to 7. And then it's negative whenever the slope is negative, so that is from 9 until we get to 11. And then it's 0 whenever the slope is 0, which is from 0 to 2, and 5 to 6, and then the last one is 7 till we get to 9. Then it says, when does the particle move at its greatest speed? Okay, so speed is the absolute value of velocity, which makes this entire graph pretty much positive. So if you would reflect all the parts that are below the x-axis above the x-axis, that would be the graph of speed. So if you look now on the graph, I drew these black lines. Those black lines represent the graph of the speed. I just reflected all the parts below the x-axis, and that would represent the speed, since speed is the absolute value of velocity. So we want the greatest speed. So we want the highest y value, which would be at 3. And so it would be at its greatest speed. We want the time intervals again. So starting at 7 until we get to 9, my velocity is at 3 meters per second. And then also at time t equals 11, because if we reflect that across, my speed would also be at 3. Then part D says, when does the particle stand still for more than an instant? So that would mean, when is my particle stopped? And my particle stopped whenever my velocity is 0. And that occurs when we look here, when my y value is 0. So that would be from 5 to 6. And it said more than an instant, so we don't need at t equals 10, because that's only at 1 instant. So that's our first example when we're given a velocity graph. The second example is when we're given the graph of position. So the following graph shows the position of a particle on a number line. And we talked about last class the difference between velocity and position, so we're using that. So the first thing says, when is the particle moving to the left, moving to the right, and standing still? So again, that has to do with velocity. But in this case, velocity is now the slope of the position graph. So velocity is always the slope of the position. So we went, when it's moving left, our velocity is negative. So we need when the slope is negative. And so that would be, if we look at our time interval starting here, which is time t equals 15, until we get all the way down here to t equals 40. And that's the only time that the velocity is negative. So it's moving left. Right, our particle moves right when the slope is positive, so when velocity is positive, and that is from 0 until we get to 10, and then also from 40 until we get to 55. Okay, and again, I'm looking at the t values to determine the intervals. And then it says when is it's moving still, standing still, and that would be when v of t is equal to 0. So that's when the slope is 0. And that would be any time, if we look here, from 10 until we get to 15, because the slope is 0. Okay, and then the last part, B, says graph the particle's velocity and speed where defined. Right, so remember, key thing, velocity is the slope of the position. So we have to find the slope of this graph and then graph that as the height, and that will give me the velocity. So I'm going to find the slope of each line segment, and so I need to find the slope on the following intervals from 0 to 10, and then from 10 to 15, which is really easy because it's just 0, and then from 15 until we get to 40, and then from 40 until we get to 55. And remember, slope is y2 minus y1 over x2 minus x1. So if I look at my points up here, this point is 0, 0, and then my point at 10 is 10, 60. And then I also have the point here at 15, 60. And then I need the point at 40, negative 40. And then the last key point we talked about was 55, 0. And so I need to find the slope between these points. So to find the slope between 0 and 10, I'm going to do y2, which is 60, minus y1. And that's going to be divided by x1, x2 minus x1. And that gives me a slope of 60 divided by 10, which is 6. And then I'm going to do the same thing for 10 to 15. 10 to 15 I can just look at, and it's obvious that the slope is 0. From 15 to 40, I'm going to use these 2 points, 15 and 40. So I'm going to do negative 40, which is y2, minus 60. And then I'm going to divide that by 40 minus 15. And if I calculate that slope, negative 40 minus 60 is negative 100, divided by 40 minus 15 gives me 25, and so that gives me a negative 4. And then the last one, we're going to find from 40 to 55, so I'm going to do y2, which is 0, minus negative 40. And then I'm going to divide that by 55 minus 40. And if you do that, you get 40 over 15, which reduces to 2.666 repeating. So those are my slopes, and then I have to graph them on a graph. So we're going to draw a graph down here. Okay, and the highest height I need is 6. And then I'm going to make my scale go the same up by 5 each time. Until I get to 55, which should be here. So each of these goes up by 5. On my x-axis or my y-axis, it's just going to go up by 1. So then I'm going to just draw horizontal segments for my slope. Remember, this is the graph of v of t, so I'm going to label it. And so from, we said 0 to 10, my slope is 6, so I'm going to draw a horizontal segment from 0 to 10 at 6. And then from 10 to 15, we said it was 0. So let me change the color so you can see it. So that would be down here from 10 to 15. And then from 15 to 40, our slope was -4. So I need to put tick marks for negative slopes. So I need to go down to -4. And then I'm going to graph from 15 to 40, -4. So there. And then from 40 to 55, I'm going to estimate 2.66, which is right here. And the key thing is, though, at each of these points, it's a cusp. So you should have open holes. So go back and draw open holes at the end of each of your segments because it's not differentiable there, which means the derivative should not exist. And remember, the velocity is the derivative. So this is my velocity, v of t. And then for my speed, I'm going to graph my speed in blue. So S of t stands for my speed. That's going to be in blue. And everything, all the positive values are the same. 0 is the same. But remember, we're doing the absolute value. So that means anytime we have a negative slope, we're just going to make that positive. So it was -4, but now it'll be a +4. And then this one will be the same. And then just remember to put open circles again on this one. So blue is my speed, v of t is my velocity. So that is what we did today in class, and then you're going to work on the free response questions that you got at the beginning of class today, because that's what we also did in class, and that is your homework. And I will see you next class.